Alright, so I'm coming to the end of my second semester as a graduate student. Again, I'm studying mechanical engineering through the University of Oklahoma, but I'm taking a lot of systems engineering courses, so they just don't have a specific degree program for that, but that's basically what it's going to be. And so this semester I was taking two courses. I was taking one called Design of Experiments, that's a statistics course, and then also Fundamentals of Systems Engineering. So today I kind of wanted to go through what the end of my semester was like, and here you'll be able to watch part of the process. So I'll start by explaining why I made 8 batches of cookies. For my Design of Experiments class, it makes sense that one of the most important parts of our class in the final was to design an experiment. And so we had to design an experiment where we varied at least 4 factors. I believe I chose 5 factors. And then you had to determine how many runs you were going to do, which parameters you were going to use for each run, and then determine which of those factors actually made a difference and what you would like to do, or what the most optimal results would be based on the results and data you gathered and the analysis you ran in the software. So for this experiment, we decided to do what makes the best gluten-free chocolate chip cookie. My wife has to eat gluten-free because she has celiac disease, if some of you are familiar with that. And so that can make baking kind of hard if you can't have any wheat. And so she has some tips and tricks that she does for substituting things in recipes, but she never really put the test and checked data to see what actually matters. So we said we were looking for cookies. I like chewy cookies. She likes cookies that are crispy. So we do chewy cookies that have a crispy edge. And then she likes them flatter. I don't really care. So we wanted maximum area for the cookies. A chewy texture but crispy edges was what we were going for. The things we were testing were the flour mixture, whether we were using almond or coconut flour for the flavor, whether we were chilling the dough beforehand or not, whether we were using all butter or half butter and half shortening, whether we were using a paddle or a whisk for the mixing, and whether we added extra egg or not. That's something that's really big in gluten-free baking, is to add more egg because there's no natural gluten. And so the egg helps to act as a binding agent to make it sticky and fluffy and not so crumbly and dry. So those are the things we tested. And so we did 8 batches where we varied different things. So each batch was a unique recipe. And the cool thing about this Design of Experiments class is if you think about 5 factors that are binary, have 2 options, that means there's 2 to the 5th possibility. So there's 32 different ways that you could make these batches of cookies. I only made 8 of them, and yet I'm still able to draw full and complete conclusions about what actually matters. So that's pretty cool. What it ended up being is that the things that mattered most for the size of the cookie were the kind of flour you used, whether or not you add the extra egg, and whether or not you chilled it. And so the conclusion that we made was that you should use almond flour, you should chill your dough, and you should definitely use the extra egg. As far as getting them to be a little chewier, fluffier, thicker, the whisk made a slight difference, which is something that we actually just tried once on a whim because the paddle was dirty, a month or 2 ago. And then we thought, maybe that actually would make a difference, with gluten-free baking, and turns out it kind of did. So from that, we're able to determine a model, determine what was important, and say these are the optimal parameters. The second big assignment of 3 at the end of the semester that we had to really tackle was also for my Design of Experience class, and it was what he called an interactive final. So we did have a bookwork, paperwork, written test, but we also had an interactive final, and what it was is he had some computer model for a process, and it had, I think, 8 different factors, if I remember correctly. And this is for some manufacturing process, so it's things like, percent of A, percent of B, how long are you mixing this thing for, where are you getting this ingredient from, blah, 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 whatever, temperature, pressure, etc. And so there were 8 factors, and what he did is he said, okay, here's the goal. You want this parameter to be above 1,000. You want it to have a high tensile strength is what it was. And so here's the starting parameters that you currently manufacture this part at. Here's your goal that you want to get to. And here's the ranges you can do for each parameter. And so again, this was like a design of experiments, except it was a virtual experiment. So you would put together the parameters you wanted to use and then send them to him, and then he would send you back data from the software that he had the model built in. And so it was a lot of fun. It was really cool. And this one, because it was model based, we were able to get a lot more data a lot more quickly. We were able to therefore use the software to make some really cool plots and see curvatures and things like that in real time, because you could take a lot of data, change the experiment, take more data. There were a few interesting lessons learned. So I designed the first experiment where I said, okay, well, here's where we're at. And so let's kind of set those as the midpoints and then use some ranges above and below that. And that went well. Got some results that were successful. Definitely saw which factors were important. It was the percentage of ingredients A and B were what mattered. Everything else was like, yeah, temperature, pressure, doesn't make a huge difference. And you were actually able to calculate something called the line of steepest descent. For those of you who are familiar with calculus, especially multivariable calculus, then you know that a lot of times it's about finding the fastest increase or decrease in multiple dimensions. And so that's all this is. It's a two-dimensional way to increase your value most quickly. And so we did that, and I used that. And however, I extrapolated my data, right? That's one of the first things in statistics you learn is don't extrapolate. Well, I kind of extrapolated it, said, okay, well, follow this line and you're going to get better and better results. And said, okay, well, we'll just follow that line all the way to the bottom of the range, down to 1 to 3% of this ingredient. And I ran the test again, and it was worse than my first experiment, or my first data set. And then because of where it was at in the data set, in the surface of experimental results, then the curvature or the line of steepest descent changed and sort of sent me off the path. So I followed that one rather than following the initial line of steepest descent that was close, and that also threw me off. So then I had to do a fourth experimental design, when really, if I had been a little more cautious, a little more careful and deliberate in my design, rather than going willy-nilly and saying, oh, I'm going to jump the gun. If it going down this line gets better, we should just go all the way down that line. It has to get better. Well, that was probably kind of silly of me. And so I ended up, not too far actually from where a couple of my data sets were in the first experimental design. And you set up your parameters, and then you set up your parameters slightly differently to make sort of this ellipse of data. And from there you can plot a surface. I'm going to hopefully be able to put some pictures in this video you guys can watch, and see where your maximum is, as well as determine from the software what the values for that maximum are, and therefore what parameter you should run your test at. So I learned my lesson about going too fast and too far because of data extrapolation. But again, I learned a lot, and in the end, he was a very lenient grader. I mean, I guess I don't have my grades yet, don't want to speak too soon, but he was always very lenient and understanding, and he was more concerned with your thought process and that you eventually saw any mistakes you made and corrected them. The third big assignment for the end of the semester was a group paper for my Fundamental of Systems Engineering course, and it was to write a ConOps, a concept of operations, which in systems engineering, that's like a very high-level early design document that basically says, this is this new idea we have, here's the current technology, here's where we'd like it to get, here's the challenges we're going to have to face, here's the components of the new system that will help us face those challenges, etc. And so we were in groups, and luckily there were 4 other students who are also full-time employees at my company who were doing this program. So we just asked the professor if we could all work together for convenience sake. So we got together, had a meeting for about an hour and 15 minutes where we each presented on some of the project documentation we'd read, and then we shared ideas, and then we sort of made an outline of our paper, split up who was going to write each section, and went our merry way. In the end, it's a 4-page paper for 5 people. Really not that bad of an assignment, right? That means we each have to write like 3/4 of a page roughly. So what we ended up going with, and this is because we have a really awesome professor, is we talked a lot about smart home automation, But we also kind of thought about wanting to do something big. Smart home automation is already here in so many ways: Alexa devices, smart thermostats, et cetera, et cetera. And so we took it a step further and said that we wanted to create the smart home of the future as based on Star Trek. So we were talking about things like the food replicator and tricorders and the medical bay that they have on there, the holodeck, the sonic showers, all sorts of things like that from Star Trek if you're familiar with Star Trek. And so in the end, it really wasn't that bad an assignment. My team was great to work with, and my professor was really cool. And that's been the really nice thing about grad school, is that the classes are smaller, the professors, already hopefully some of your professors, you feel like they're on a more peer-to-peer relationship. Obviously they're your professor, obviously they've been in the industry, they know more than you, that's why they're teaching you, but it's more peer-to-peer than it was in high school, right? Well, in grad school, I feel like that just continues to become a better and better and more equal and relaxed relationship. So, in freshman year writing a paper, or in high school, I don't know if I ever would have written a paper like this for such an important grade. It seems a little bit wacky. But here, with this professor, he's made it very clear that the important thing is the concepts, the important thing is learning. And so if we want to write a paper about how to build a starship, good on us, and then he's probably going to be really excited to read it, we hope. But yeah, so this means I'll be finished with 3 of 10 classes for my master's degree. I'm going to be taking one in the summer, and it's a term class. It's actually only 5.5 weeks long, which is kind of going to suck because it's going to be 2 hours a day of lecture. And I don't know if that's going to mean 1 or 2 homework assignments per week, which I know sounds great compared to what undergrad was like. But, it's going to be a heavier load to take that one class in 5.5 weeks than it has been to take multiple classes at a time this past semester. But it does mean I'll get the second half of the summer off, and so I'll have no classes from the middle of June until like the end of August. So that'll be kind of nice, and hopefully I can push out more videos and share more with you guys. I definitely want to be making a lot of videos for people who are going to be interning this summer, share my internship experience more, and give you some specific advice on what it will be like, how to do your best, how to give a great presentation, and hopefully end up with that return offer a lot of people want. Also might be able to finally get to some of the interviews that I've always wanted to do on the College Guide with recent college graduates to learn about their majors and share that information with you guys as well. So thanks again for watching, and we'll see you next time.